A cuttlefish hunt has 3 phases. When a cuttlefish first notices something that might be food, it enters phase 1, attention. The cuttlefish turns its eyes, head, and body so that it can look at the food. It may also change its skin color or lift some of its arms. Then, during phase 2, called positioning, the cuttlefish moves closer to the food until the cuttlefish enters phase 3, seizure. The cuttlefish pushes 2 tentacles out from where they were hidden just above its mouth, using its 4 middle arms to point the tentacles. The cuttlefish then throws its tentacles, a moment we call Tentacles Go Ballistic, or TGB. Now, let's watch a cuttlefish hunt some robotic prey. At one end, we offered the cuttlefish robotic prey, or chunks of shrimp on a skewer moved by an Arduino-controlled motor. At the other end was home, a spot where the cuttlefish can hide. Meet Ender, our cuttlefish hunter, species Sepia officinalis, age 15 months old. As the robotic prey on the left enters the water, we see Ender turn suddenly to face the robotic prey, clearly displaying the attention phase of the hunt. Now Ender moves closer to the robotic prey, the phase also known as positioning. Finally, we see Ender push out 2 tentacles, then suddenly fling the tentacles ballistically towards the robotic prey, all as part of phase 3, seizure. Now, let's take a closer look at that tentacle shot. The video frames have now been manually aligned and cropped such that the cuttlefish is always positioned at the same location and orientation in the frame, making it easier to observe and analyze the changes to its body pattern as it hunts. This time, it is much easier to observe that as the tentacles return to the mouth, a high contrast and very visually conspicuous body pattern appears, even as the tentacles are still being pulled back into the mouth. It turns out that our cuttlefish show some kind of high contrast body pattern after every successful tentacle shot. In this matrix video, you can see every successful tentacle shot made by one cuttlefish over the course of the entire study. Notice how a high contrast and super visually conspicuous pattern appears after every single tentacle shot and lasts for at least 3 seconds after tentacles go ballistic. In this next matrix video, you can see every unsuccessful tentacle shot made by one cuttlefish over the course of the entire study. Notice how a high contrast and very conspicuous body pattern appears briefly, but then very quickly disappears. This post-attack body pattern is very visually striking and often observed in wild cuttlefish, which is actually very weird. Given that cuttlefish survive by hiding, why would they become more visible just when they've caught their food, when they are more likely to be distracted and vulnerable? We now believe that this unusual body pattern, which we call the Tentacle Shot Pattern, or TSP, is meant to startle any nearby animals that might want to hunt and eat the cuttlefish. The tentacle shot pattern might make these potential predators halt or hesitate for a brief moment, giving the cuttlefish an extra second or 2 to deal with its food before hiding itself again with camouflage. Based on what you've learned today, can you guess whether these tentacle shots ended in a catch or a miss? Carefully describing and defining behaviors can help us more easily teach both computers and humans how to recognize these behaviors, which is super useful when studying the link between nervous systems and behavior, especially when studying animals as delicate and unknown as cuttlefish. Because cuttlefish use their central nervous systems to directly and actively control their rapidly morphing skin, if we can develop better ways to film cuttlefish in great detail while the animal is free to move and live naturally, we can study their brains and nervous systems without cutting open any part of their bodies. To learn the details of our analyses, watch more movies, or explore the original dataset, please visit www.danbeekim.org/openlabnotebook/cuttlefish hunting behavior.